Hello, everyone. In this video, we will go through some examples related to survival functions. Let's take a look at the first example. Given that F0t equals t over 100, calculate the probability that a newborn survives beyond age 30, the probability that a newborn dies between ages 65 and 70, the probability that a person aged 30 dies before age 80, and then the last one, the probability that a person aged 40 survives beyond age 75. In this example, we can see that F0 at t equals 100 equals 1. So in this model, we have an upper age limit. So here, omega equals 100. All right, part A, the probability that a newborn survives beyond age 30. We have the event T0 greater than 30. Obtain the probability expressed in terms of the given distribution function, which is 1 minus F0 of 30. Substitute t equals 30 into the expression, and we get the answer 0.7. Part B, the probability that a newborn dies between ages 65 and 70. We want to get the probability of the event that T0 is between 65 and 70. In terms of the distribution function, this probability equals F070 minus F065. Plug in t equals 70 and 65 respectively. Upon calculation, we get the probability 0.05. And then part C, the probability that a person age 30 dies before age 80. We have the event T30 less than or equals 50. 50 is the future lifetime of a person age 30, okay, dies before age 80. So the future lifetime is 50 years maximum. We need to get the probability of this event, but we are given the distribution function of a newborn F0. So the next step is to convert this probability in terms of T30 in terms of T0. So this corresponds to the probability that a newborn dies before age 80, given that this newborn already survived up to age 30. This conditional probability can be expressed as the probability that T0 is between 30 and 80, so this event, over the probability that T0 is greater than 30. Expressed in terms of F0, substitute t equals 80 and 30 respectively. Upon calculation, we get the probability 0.7143. And then the last one, a person age 40 survives beyond age 75. We have the event T40 greater than 35. Express this probability in terms of the random variable T0. This corresponds to the probability that a newborn survives beyond age 75, given that the newborn has already survived up to age 40. Expressed in terms of T0 and the corresponding distribution function F0. Substitute t equals 75 and t equals 40 respectively. And we get the answer 0.4167. All right, so let's move on to the next example. We are given that S0, and we would like to calculate the probability that a person age 65 dies before age 85. So we have the event T65 is less than or equals to 20. We have F65 of 20 equals 1 minus S65 of 20. But we are given S0, so we need to convert this S65 in terms of S0. We get the relationship between S65 and S0. S65 20 equals S0 85 over S0 of 65. From that, we can substitute T equals 85 and 65 respectively. S0 65 equals to this value, 0.0146, and S0 85 is 0.00073. Plug this back into the expression here, and we get the desired probability. The probability that a person age 65 dies before age 85 is 0.9502. The next example. Given the survival function at age 15, S15 equals to this expression, calculate the probability that a person age 20 survives to age 75 but dies by age 84. This survival function, S15, evaluated at t equals 95, this is 0. So here we have an upper age limit. A person aged 15 can survive for 95 more years at most. So 15 plus 95, we get 110. So the limiting age is 110. Get back to the question. We want to get the probability that T20, a person age 20, survive to age 75. So the future lifetime is at least 55 years, but dies by age 84. The future lifetime is 64 years at most. So the event is T20 between 55 and 64. We are given the survival function at age 15. So we need to convert S20 to an expression involving S15. And we have the relationship linking S20 and S15. S20 of 55 can be expressed as S15 plus 5, where X is 15 and T is 5. And therefore, we get S20 of 55 equals S15 of 60 over S15 of 5. Considered a person at age 15 survived to age 75. So altogether, the future lifetime is 60 years, starting from age 15. So we have S15 of 60. Given that this person at age 15 already survived for 5 years, reaching age 20. So over S15 of 5. So this is the expression for the first term. And then the second term, S20 of 64. This equals S15 of 69 over S15 of 5. All right, so all the terms is in the form of S15. So we simply do the substitution T equals 60, T equals 69, and T equals 5 respectively. S15 of 5, we get this expression, and then the probability is 0.973. And then we can also calculate S15 of 60 and S15 of 69. Plug it back to the expression. Upon calculation, we get the desired probability 0.0861. That's it for today's video. Thank you for watching, and in the next video, we will go through some actuarial notations.